Okay, all right, good. This is advanced and even advanced. Okay, so here's the take home, because it is late in the afternoon, and I apologize for dropping in right at the end of the day here. But we all know M Health shows a tremendous promise, right, for reducing healthcare costs and increasing outcomes. And I'm hearing just some of the presentations, and clearly, there's this need we all feel to get it out in frontline. It really needs to touch the people, as opposed to being in a lab or being, sold or something. It really needs to hit the front line. And what I'm hearing a lot, both from my colleagues in academia and also in industry, is there's a focus on I've got my app, it's targeted, it's got the MVP, it's got the value proposition, and I'm gonna sell it out there to doctors or consumers or healthcare organizations. And I put on my physician hat, and I think I don't think that's gonna work. I don't think we can just be building apps and selling apps. And I know it's really hard to think of how can we not be thinking about apps. So I'm just going to put it out there and see what you think about it, okay? Because I think just going for there's an app approach, it cuts against a dominant pattern of how we as clinicians use technology. I'm a primary care physician, and it's difficult to adopt for patients who have multiple conditions. And most patients actually have multiple conditions. And also because M Health is so new, things are moving so fast that if we focus on one thing, I think it's easy to sort of get bought into or stuck in a self-contained approach that isn't going to be as flexible enough. Okay, so these are some postulates. I'll talk it through, and we can argue whether that's an appropriate way to think about the landscape right now. The guiding principles I hold are whatever we do, M Health data needs to support sound inferences. Right? We need to be thinking about confounders. We need to think about accuracy of data. It's not just whatever comes out of the app is true, right? We got to keep all the skepticism we've had in the rest of science of data. Support sound decision making. The data standards are critical is a postulate for personalizing the use of M Health for patients with multiple conditions. That's really the bulk of my talk here. And that the solution includes open approaches. And the key terms that I will be bringing up that are technical terms are syntactic data interoperation and semantic data interoperation. We hear a lot about interoperability, but there's sort of this big split between the two that I really want you to understand, if nothing else, from this talk. Okay? So whenever I transfer Mac to PC, the little percent signs come out, so it's kind of interesting. So there are, I think, two fundamental ways that M Health technology can improve health outcomes. One is through from the bottom. M Health interventions, many that you're all imagining and working on, help people do self-care, and that improves outcomes. Another way is that the data that's collected from mobile health provides data-driven insight that supplements self-care, that leads to better outcomes, and of course many solutions include both. But I want to look at the M Health data where it comes from. It comes from passive sensors like your Fitbits and whatnot, and it comes from active self-reports, your PHQ, your stress, whatever it is, right? So two different modalities. And the challenge is that with over 100,000 apps, out there on the App Store, and many more to come, most of them address just one single disease, right? It's a hypertension app, or a heart failure app, or a whatever app, and we have to think that way, as clinicians and many of us as specialists. But that half of Americans have one chronic disease, a quarter have two or more chronic diseases, right? And most of us want to bring together our unique combinations of data outside of any one app, right? All of us are unique. All of us have different constellations of health challenges. So for example, someone over here might want to track sleep, physical activity, and blood pressure, and someone on this side of the room wants to track pain, anxiety, and caloric intake this week, and next week they want to do something different, right? And so if your app is so carefully thought out what data they're going to collect, and next week they want to collect something different, are they going to not use your app? Are they going to find another app? Think about the experience and the point of view of the person, right? I mean, I track, and half the time I track this, and then I track that, and so if we take a look at what kind of data we need, then it's combining different data regardless of sensor or app. It's building smart sense making on that data, and then we want personalized clinical insights at that time for the problem we have, whether you're a clinician, whether you're a patient, or in fact jointly. So that's the challenge. What we have is really, all kinds of sensors and self-report, all this kind of data coming together, and it drives both insight and patient-family self-care that leads to better outcomes. And so in this view of data flow, it's data integration and data analytics that is really at the heart of digital health promise. Certainly, apps and solutions always have to be sort of, the thing you download, the thing you put on your phone. But I think fundamentally the promise is one of data integration and data analytics, right? And so if we were to think that way, maybe, stepping up to like the 30, 50,000 foot level, we need to break out of focusing on apps and start thinking about the data and on making sound inferences with the data. We're early on in mobile health as a community, as academics, as scientists, as developers. We should be thinking not just of our own solutions, but we should be thinking, how are we going to advance together? How are we going to advance together as a science? How are we going to advance together as technology that's really going to help people? So it might be helpful to be thinking about, let's jump up from the app space and go to the data space. So let's be a little bit more, domain focused, now that I've said we should be general. In 2010, hypertension obviously cost the United States loads of money, continues to do so for medication services and missed days of work. And of course, to manage hypertension, these are sort of the data streams that we might want to, pull in, right? And of course, there are many different ways of getting weight, right? Even just the wireless scales, there are quite a number. Wireless blood pressures, more and more solutions for medication adherence, maybe some that you guys are working on in here, right? So we need to pull data from many, many devices together. But let's focus on one, which is minutes of moderate activity. And as you probably know, most of the guideline organizations around the world, all say we should be exercising 150 minutes per week of moderate intensity, which is 3 to 6 METs. So there's a very clear definition of what moderate intensity means, or 75 minutes of vigorous intensity activity. So, rare of all things, we actually have guidelines that agree with each other, right? So, here we are in clinic, and there are sensors out there. So can we actually track this data and use it clinically to tell our patients whether they're achieving goal or not? Seems like, well, if there's a low-hanging fruit, this ought to be it, right? So this is a state of M Health interoperability today, and we'll use the physical activity case as a study because it is, I think, the most advanced in a sense. There's the most to talk about, okay? So many of you know what an API is, Applications Programming Interface. It's a piece of software that sets requirements on how one application or one device or one data source talks to another, okay? That's all you really need to know about it. And many companies offer APIs so that other systems can access their data, right? How many of you have used the Fitbit API or the Runkeeper API? So you get that sense, right? It sort of tells you how to get at stuff, and it's very helpful. You can get your stuff out, and in fact, there are services like Validic. I've just heard about Harvard's Dataverse that has a Fitbit API. Fitabase is another company that works in, there are services out there that will help you get data out of, all these APIs, right? Right? How many of you use Validic or one of those data aggregator services? They're handy, right? So I guess we can ask, well, is the silo problem solved? Okay? Is data interoperability solved? We've got Google Fit, we've got Fitbit. So some of these are actual devices themselves, like Runkeeper and Fitbit, which are also aggregators. This is health. Validic is a commercial company that brings devices together, device data together. Is the silo problem solved? Let's take a little more careful look. This is Fitbit data for activity, and it gives you a number of fairly active minutes. I don't really know what fairly active minutes is, and actually it's kind of hard to find out. Okay, it's not well defined as 3 to 6 METs or more than 6 METs. It's just fairly active minutes. Okay, so if I'm going to match it to guidelines, a little bit hard. Okay, let's put it on a table. What about Google? Google gives us an enumerated list of numbers that corresponds to an activity that can be specified, a duration in milliseconds, and num segments, which I'm not actually sure what that is. So in other words, we get a number which corresponds to an activity. So let's say road biking and a duration in milliseconds, then we can go somewhere else like the 2011 Compendium of Physical Activities and find road biking, 14 to 15.9 miles an hour, racing or leisure, fast, vigorous effort. Okay, so that would be 10 minutes. If you're racing and you're not drafting, then it's 12. Okay, so you can do that, and you can infer the METs by your type of activity and add up the minutes at 3 to 6 METs. And you're probably sitting here thinking, oh, that's a little kind of fudgy, it's a little weird. But if you wanted to know unicycling, it's 5 METs. So it's really useful. Okay. All right, so that's Google Fit. So, okay, what about HealthKit, right? New on the block, Apple does everything right. Workout activity, well, they have cycling too, but I don't know how the cycling compares to the other one. But it doesn't really matter because we have the actual time. The difference between the start and the end date is it's actually down to the second, and the distance. So from that, we can calculate duration, distance, and METs. And we can add up the minutes at 3 to 6 minutes, okay? So this is sort of the gnarly underbelly of data modeling, okay? And this is for something really pretty simple. It's objective, it's physical, these are quantities everybody understands, and it's still actually a real mess, okay? Now, obviously, some of them just calculate it out for you, but then you don't know how they calculated it. So the question of, is the silo problem solved? I would say for syntactic data interoperation, yes, okay? Syntactic data operation means getting data from one source or device to another. I think of it as the pipes, how to get data from one place to another, okay? From Fitbit to Epic, from glucometer to your nutrition app. It's the pipes, okay? And there are lots of proprietary integrators out there, like HealthKit or like Validic, and what they do is they take all the little pipes from the iHealth or the Y-Things or the ARIA scale or whatever, and they build bigger pipes. So all you have is one pipe, the HealthKit pipe or the Validic pipe, okay? So that's great, okay? One pipe is better than many small pipes. But I would say what they do is that when they build those pipes, number one, they're focusing on fitness apps mostly, right, and fitness sensors, and they're doing that aggregation, that integration, driven primarily by commercial needs and sort of consumer needs, and less so the scientific and care needs, okay? And maybe for activity that's not so important, but if we get to blood glucose, right, if we're getting to O2 saturation, I'm not sure I want like a commercial company like Validic, doing the standardization around O2 stat or something, right? And even Apple, we've been talking to Apple quite a bit, and they say, we don't know this domain, we don't know medical data, it's your guys' job. Like we're just putting it together and just giving you the data, okay? Good, I think that's an appropriate realization, okay? So how do we have a meeting of the minds here? What's really needed? Because what happens is when we have a bunch of data coming in through a big pipe that doesn't take care of the problem of what's in the pipes. The semantic interoperation is what's coming out of the pipes. Is what you meant going into the pipe the same as the meaning coming out at the other end of the pipe? And if it isn't, and you're trying to make clinical decisions on that, I think we should all be worried, okay? So is semantic interoperation handled now? And I would say no, okay? That clear semantics are critical to ensure that we know what we're talking about, that we're talking about the same thing. When we start interchanging with the electronic health record, we need to make sure it's the same thing. If it's a fasting glucose, it matches a fasting glucose, not a random glucose. Okay? If it's a recumbent blood pressure and we need to make the distinction between recumbent and standing, there's a way that we can make that distinction. And of course, we've been doing this in health standards forever with SNOMED and Loinc and RxNorm and all those wonderful standards that our HR colleagues need to deal with. Okay, so one thing is sort of semantic labeling with vocabulary standards. So we don't need to reinvent them, we just need to use them properly. Sound inferences is really important. I need to know when that value was collected. I just simply need to know. Was the blood pressure that's reported, at the time that it was stored in the cloud? Was it at the time that the patient entered it in? Was it at the time the patient actually took the value, okay? Is it important to your use case? Maybe it is, maybe it isn't. What you need to know time zones, okay? If you're a diabetic and you travel a lot across time zones, do you know, are you 3 hours off all the time, okay? Provenance, is the weight self-reported or is it measured by a scale? Obviously, that's quite important. Algorithms for calculated values. If somebody's calculating METs, is that an algorithm that's correct or not, or is it a fundamentally inaccurate algorithm? Measurement error, very important, right? If we're going to take in loads and loads of data and we're going to add it all up and we're going to calculate on it and we have no notion of error, that's a problem. So as part of the MD2K project, I'm learning all kinds of things like, what is the error on your GPS measurement? I didn't know. Now I know a little bit more. All sorts of things that really, if we put on our scientific hat, we need to be as critical as ever. Okay, and this is not the stuff you get out of a Fitbit API, right? So what we have then is a bunch of data coming together to drive data-driven insight that provides better outcomes through self-care. So what we need to do, moving from sort of apps to data, is we need tools to help us get data out of multiple devices. So this is the notion of bring your own device. You don't want to build your solution or your app to only work with Fitbit, or maybe that's okay because that's the biggest, product on the market. But then maybe, maybe something else will come. And, now do you work with Jawbone? You want to bring your own device, right? You want to allow people to bring their own device. You want to make sure that as you get data out of these devices, that it comes out in a way that is clean, that meaning is maintained, and ideally it's the same across, so you don't need to keep remapping your data, right? And finally, what you're doing this because you want to make sense of the data so you can give insight to the patients or educate them or help the clinician treat, right? So you want to make sense of them. So we need all three of those. So what's the solution? I'm with OpenEM Health, which is a nonprofit company that I started with Deborah Estrin, who was here from UCLA. This has been about 4 years now. And our task is to introduce open source tooling to foster data integration across M Health to advance both care and science. And we're doing it in 3 fundamental ways. One is open APIs. For those of you who are techie, we basically use the same old modern technology that most everyone else understands. It's not XML, it's not RDF, it's sort of standard stuff that a typical developer, modern developer would understand and can use. Open source common schemas, a common way to express things like minutes of moderate activity, so we don't have things like activity enumerated list, so how do we represent things in ways that are clean? And then most importantly, actually a community of developers, and I hope people like yourselves, researchers and clinicians and patients, who will join together to sort of chart a course forward together on APIs and schemas and methods. So what are we doing? We provide tools for standardized data, store data, integrate, and share data. All of this is open source. All of this is free. Not too many things in life are free. This is actually free. So to start integrating data, for example, we have a shim, which is pretty easy for you to just download, and it will get you at the data that's made available by Fitbit, Runkeeper, YThings, iHealth, HealthKit. We're incorporating all of those. And it's your developer, it's pretty easy for them. They just download it, and boom, you can get the data out of those. And what's nice is that it comes out as standardized schemas. Okay, so when the blood glucose comes out of any of these data sources, it's going to look the same. Okay, and it's going to have things like timestamp on it, and provenance on it, and units on it, and those are going to be properly modeled, and it's going to be annotated to SNOMED, so when you cross-reference it to your EHR, it's going to be there. Okay, so we have a growing list of schemas of measures that are important. I want to get back here. We have a special tooling for getting data out of HealthKit on the iPhone, because it's actually really hard to get data out of HealthKit, and even when you do, it's a mess, I will warn you. We also have a collaboration with a company called Catalyze. It's a sponsor of our company, of OpenEM Health, and that one allows you to get HL7v2 data fed out of the EHR, and it also has data being put into the EHR, but if you're interested in that, we can talk offline, because I'm not sure that you want to do that, but anyway, you can get data out. So I think for the schemas, right now we're modeling, standard things like height and blood pressure and weight and things like that. But I'm interested in these newer measures that I think are going to be really exciting in the next, 1 to however many years, right? Overeating, I think that's a really interesting one. Gait, salt intake. So we're working on congestive heart failure. I hear there was a CHF case study earlier, right? In MD2K, we're coming up with sensors that measure lung water congestion and, trying to reduce readmission, of course, like everybody else. And we'd love to get a measure of salt intake. Well, how could we do that? I'm not sure, but I'd love to think that through. What are the measures that matter that we can act on? How can we build out new sensors? How can we build out new structured assessment apps? Who needs to come together? It's industry, it's academia, it's health and engineering, and design, and computer science. It's clinicians, it's end users, it's working together. We have run one of these group meetings on medication prescription and adherence, sort of a meeting of minds of developers and from industry, and like Mango Health, for example, and PillPack. These are companies you may have heard of, sitting with pharmacists from UCSF, general internists from Columbia. Really interesting. We're going to be doing one of these with Stanford Mobilize, one of the BD2K centers on physical activity in the spring. And the thing is, we want to co-design data schemas. What's the important metadata? How should we be thinking about the data? How do we test, evolve, and validate these measures? And then when we're hopefully done with some, we can shove it into the OpenEM Health library and people can use it. So we're not clear yet on how this process works. I think it's something for our community to think through. What are some new measures? What's important for us to work together? How do we work with industry? Industry really wants to work with us. They have no clue how to work with us. We have no clue how to work with them. So it's a lot of work to do. Once you have the data out of the devices and you have it in a standardized form, you want to do something with it. You want to process the data. You want to have algorithms on it. We will have open source modules. For example, minutes of moderate activity. We have that already. We just need to package it up and send it out. And of course, you can have a module that you can reuse because it's plug and play. All the data comes out in a standard representation. You can plug and play into reusable processing modules. So look for this from mobile data to knowledge. MB2K is going to be developing all our processing modules for eating detection, and everything that we're doing is going to be open source and will be made available in OpenEM Health compliant way. So it'll be here or in the MD2K website, but it will be OpenEM Health compliant. We also have a visualization library because clearly sense making involves visualization as well. We have designers on staff that have designed nice ways of thinking about displaying blood pressure data. These have been done in lots and lots of participatory design sessions with patients and clinicians, both nurses and physicians, about how we might want to display some of this sort of very common data. And we'd like to build out a library of O2 sat and insulin and medication adherence and things like that, so that you can kind of look through and use ones that are useful to you. So I would say that we're coming on an era of new sciences of digital health. These are some of the things that I think are extremely interesting. The definition and validation of clinically useful measures that are made possible by these technologies that are in our hands these days. Data interoperation continues to be very important. There's both the syntactic interoperation, the pipes, which I think the commercial world is taking care of, and the technology certain that's actually really easy to do. The semantic interoperation is very hard. It's very hard, but that's really what we really need to focus on. Once we do that, I think we want to get this virtuous cycle of methods and algorithms for inferencing and decision support, and that obviously needs to be done in the context of clear use cases and clear products like you're working on in this whole week. And then I have not talked really about data sharing and privacy security. That's many lectures that someone else can give. I'm not that expert in that, but it's really important. So I would say for your projects and your work, it echoes some of the comments, I guess, from the earlier session. It's actually really, really hard to figure out what your clinical use case is. What is your special thing that you're trying to solve? Whose problem are you trying to solve, right? And if you think about the patient, you can't think about just their disease, because patients have a lot of diseases. I'm a primary care physician. Most of my patients have 2, 3, 4, 8 diseases, right? So solve it from their point of view, not from the disease point of view. Obviously test your solution with real clinicians. And I think you'll find as you do that, maybe you're providing data, maybe you're providing an intervention, maybe you're doing both. To what extent do you want to go where they are, which means go where their devices are? What data do you need to capture from them? What are you going to pull in from other sources? How are you going to contribute your data back out to other sources so that your app fits in with how else they're living their lives, like with the EHR or with their version of Epic or their Runkeeper, right? How does your solution fit into their whole environment, right? And then the last point is, are you using and contributing to shared software so we can all do better together faster? Now, clearly, it's totally fine to do proprietary software as well. I think it's just have it in your mind that sometimes it may be worth doing open and sometimes it's maybe worth doing proprietary. But, there are options and there are pros and cons of it. Certainly, come join us at OpenEM Health if you're interested. I think there's lots of stuff we can do together. So stop and take questions.